Charon. Rome forged a weapon so volatile, most modern engineers still struggle to understand its physics. It weighed over 2 tons. It paralyzed the greatest fortresses on Earth, every inch of it built by carpenters who had never seen structural steel. That was the 3rd century BC. This is the Torsion catapult. The machine exists because of what happened on the battlefield. Wait, Rome literally had 0 ways to break solid stone walls. Legionaries went to the fortress. They never got inside. Every sword they swung was useless against limestone. Now watch what they actually built.
But generals warned, if this machine fails, it could make the siege camp far deadlier for the user. 300 BC. Heavy stone walls ruled the Mediterranean. Their defenders moved at 0 miles per hour, but held absolute superiority. What came next was unstoppable. They didn't parry incoming arrows. They absorbed them. Not a skirmish, a pure physics problem tearing through infantry morale. Nothing in the valley survived the stalemate. 90% of frontal assaults failed in that single hour. Every engineer in the Republic took notice. The continent's strongest limestone blocks,
destroying legions from above. It did not break them in combat. The sheer height of the walls stopped the advance, eroding the formation. The infantry starved. That is the engineering problem. Wooden bows maxed out at 150 pounds of draw weight. The composite bow snapped if scaled up. The mechanical sling lacked precision. How do you design a machine to shatter the greatest stone walls on Earth when wood physically cannot bend far enough? Here is the brutal truth. This weapon was never designed to bend. Here's the crazy part. Most of this machine's genius is biological and mechanical. Only the timber frame shows. Engineers modeled this system hundreds of times using small models before placing one single giant on the field. A 2-ton solid oak frame installed straight into the mud. 300 separate carpenters. If even one builder gets the mortise joint wrong, a gap opens in the structural block. The frame explodes immediately. 0 tolerance. Before one frame is assembled, survey teams harvest forests. No, they harvest slaughterhouses in the dark. Every strand of animal sinew is refined. 3 materials: sinew, iron, oak. Each requires completely different mechanical engineering underneath. First task, reverse engineer the tension that destroys them. Study every failure mode. Then build a new spring deadlier with a trigger. 40 machines built piece by piece before a single legionary touches the wall. This step takes months. They stripped entire regions of animal tendons and human hair. The raw fibers follow the engineers within minutes, always. The enemy's height gave them absolute control on the field. Every single minute was counted. The legionaries cannot even scratch a 40-foot wall.
The battlefield is dangerously vertical up there. The torsion catapult spreads the load. The artillery points a wooden arm. Simple, effective. Crisis over. They are building a massive kinetic energy storage device standing straight up in the active combat zone. Right now, mechanics guide a massive solid oak beam into the baseplate, mortise and tenon joints. Carpenters hammer the wooden pegs through the joints. They hammer seal the structural block. They must cut the oak to a perfect 0 millimeter clearance. One loose peg, the joint shifts under pressure.
Charon. When the machine fires, that joint bursts and takes the crew's heads off. They check the joint tension by hand. They cannot see the enemy wall yet. They must trust the geometry completely. After the frame comes the spring. Hand-woven bundles of animal sinew stretching straight through the top and bottom of the frame. Between the sinew and the wood sits a heavy iron washer, the modiolus. Miss it. The tension slowly bleeds away momentum. After weeks of twisting, the machine enters the testing ground. Watch what comes next.
That 2-ton frame fights the expanding torsion, not the arriving enemy. Spring release is what destroys catapults. One asymmetric twist touches the chamber. The entire alignment is now locked. Drop the trigger claw first, crush the mechanical bonds. Then the throwing arm drives straight through the vertical stop. Clean. The twisting sinew trying to break out is more dangerous than arriving defenders. Backwash pressure pulls the oak frame with it. 300 engineers running full speed across the trench. One breakdown stalls the whole firing cycle. Millimeter-wide iron teeth. No more, no less.
Too loose, and the arm never reaches the muzzle velocity. Inside every catapult frame, forged iron reinforcement, like a modern engine block but directed at the wall. To seal the tension of the sinew, a forged iron capstan is used, a heavy iron modiolus sealing the torsion chamber. It anchors the twisted fibers to the wood through a locking pin. Miss 1 millimeter during rotation, the explosive energy rips the throwing arm sideways into the soldier's skull. 100% symmetry, or the centurion shuts the attack down. Every single catapult tested here. Pluck the sinew bundles like a harp string.
Listen to the pitch. The left and right bundles must match perfectly. If the left sounds a semitone higher, the right arm pulls unevenly. At 85% symmetry, the frame cracks open and kills the crew. The master artillerist tunes the weapon entirely by ear in the middle of a screaming battlefield. He rotates the modulus with an iron wrench. 1 millimeter turn locks the pitch. 60 days until the harsh winter arrives. Counting that iron capstan is the machine's internal locking mechanism. Well-forged iron stops the tension permeating through the fibers separating. One wave of uneven release, the wood rips apart. The entire artillery line dies. A locking iron network inside the top and bottom plates. Cover the sinew with animal fat before every battle. Always. The windlass hits the catch. Thousands of legionaries are watching. This is the critical part. This machine has a massive iron claw locking it down. Engineers watch it breathe and creak every day forever. The windlass uses a ratchet and pawl mechanism, bronze gears grinding against iron stops. The pawl clicks into place. It holds exactly 3,000 pounds of force. Sharon. One slipped tooth on the bronze gear, the windlass spins backward instantly. The wooden handles shatter the operator's arms into dust. Zero tolerance on the gear ratio. The sinew rope is boiled in oil and fat. Too tight and the frame snaps, too loose and the stone falls short. The trigger pin must perfectly release the claw before any soldier steps forward. One bump creates a misfire. 3 mechanisms, 3 jobs. Grip the bowstring, seal against slippage, carry the kinetic load. All one trigger. If one of these iron claws bends in the forge, it ruins the entire week's schedule. Charon. Every pin connects the release lever to the hook. One snapped pin breaks everything. Leverage flows through every lock. Perfect drop, no bouncing. That claw must resist a terrified artilleryman pulling it hard. Wrong angle and the iron claw jams on the string. One bad drop fails the whole battery today. Listen to that crack. Solid impact means good penetration. A hollow thud sound means this stone shatters harmlessly. Zero tolerance for defects on primitive artillery. That solid oak frame is worth a fortune. It still gets burned down if imperfect. 40 massive catapults on unstable muddy fields. Spotters at every flank. 300 engineers to cover. That wood is seasoned, dried for years, cut to 12-inch thickness. A wind gust blows the rain onto a 2-ton wooden block. That frame takes a mechanical shock of 10 Gs. It must hold for 100 battles. A 60-pound limestone sphere sounds boring until you picture a kinetic transfer ripping each fortress wall apart. The tighter the sinew, the deadlier the stone seals its trajectory. Spherical rocks carved by hand. Straight flights on curved arcs. 2 millimeter release deviations opening. Force pushes through and undermines everything below. If the stone is too heavy, it jams the throwing arm. The machine becomes a self-destructing bomb. Custom-forged iron joints. Every gap closes to 0. One frame perfectly sealed. 1 minute seals 40 shots, but the siege clock is counting down. 3,000 men charging simultaneously. The torsion design throws the enemy's vertical advantage back against them. One detail protects thousands. The modulus mechanism grabs every twisted fiber below through iron teeth. One integrated structure, not individual stacked ropes. Tension maxed at 3,000 pounds of pressure. If it fails mid-pull, a shear fault forms. Weapon compromised. The only decoration on 40 catapults, a bronze plate on the front. They measure the penetration depth for 5 years after completion. Monitoring never stops. Iron, sinew, oak. From outside, it just looks like a wooden box. It is not. The fiber mix matters as much as the wood. A failed mix is what killed the early prototypes. If the sinew twists too loose, the energy must go somewhere safe. The wooden frame is that escape route. They soak the fibers with fat and marrow, braiding the strands.
Pressing it into the modulus and locking it. 300% more elastic power. 100-pound sinew bundles. Each fiber must stretch uniformly, or the entire reaction shifts in the first release. One strand always pulls inward, catching the next fiber beside it. That interlock absorbs mechanical shock on impact. They are not twisted randomly, they are woven. They find their own unstable equilibrium. Chaos creating order. The gaps between the wooden joints are not a weakness, they are the mechanism. Force flows through. Wall superiority dissipates. One artillery crew completely reloads.
Now imagine that multiplied by 40 tons of flying limestone. There is a formula for this. Kinetic energy input-output, minimum stone weight. 40 volleys per hour. 40 machines of front line to stone. This firing line never stops, day or night. Below the impact line, shattered limestone blocks pile up unseen. Sound shows what no eye can reach. The 60-pound stone exhausts the wall first. Every catapult section is tested in a firing range right now, and some results are unexpected. 300 men in the battery, each one a death trap if a single trigger fails to release.
The front stanchions are twice as thick as normal. This is exactly where mechanical forces concentrate hardest. 3 seconds from pull to impact, the only window before the enemy archers fire back. A lever pull triggers automatic drop, no aiming needed to push it. Charging starts. Throwing arm begins snapping forward immediately. 15 millimeters clearance, 60 pounds of stone, 40 kilometers per hour wind blowing the projectile, 1.5 times design tension. If one of the modioli breaks, the machine completely fails. A defending guard caught under this volley when the trap triggers, the armor crushes in 3 seconds.
A 10-foot wooden barrier must seal the engineers together before the arrows separate them. Stored open at the winch, leverage closes it. Human strength fails. The throwing arm still comes down. 40 catapults, 1 command flag, 4 minutes 20 seconds to reload. Rome drills this every day on the mud. 300 men, 1 signal, every winch, every trigger. The weapon thinks for itself. In heavy rain sections, there is no firing. The sinew stews locked under a hide cover. Leather covers 2 millimeters thick. 50 kilometers per hour winds during the storm. Cover bolted to frame. Nothing moves.
A 2-ton machine aiming in 10-meter formations. Watch what happens. The enemy wall loses integrity in 30-knot winds. That 60-pound stone drops exactly on its mark. The new engineering core is stronger than the architectural record it replaced. Always build back stronger. If this sinew fails the tension test, the entire week's batch goes to the fire. 2 millimeters of slack. The wood inside will not see rot for at least 10 battles. The independent engineer can fail any machine and order it rebuilt. 300 crews under that pressure constantly. Twice the design load on the internal frame.
Carpenters watch the wood flex. It holds well. 14 millimeters of differential expansion across 40 catapults. Exceptional. The siege of the fortress strikes. 10,000 enemy defenders attack. All 40 triggers are now pulling simultaneously. 0 burst frames, 0 uncracked walls after a real volley impact. That result is extraordinary mechanical performance. Watch this. The dust is clearing on the last section. The last defensive tower is down. The fortress is almost sealed, almost theirs. A scout is watching the full line right now. What it witnesses will change engineering forever.
These machines are not just wooden boxes. They are the death of vertical warfare, designed from biological science. Legionaries walk across the rubble now, march forward, conquer every citadel. The impenetrable war became a firing range.